Hi to all. Today's topic is conversion of galvanometer into ammeter. Let us start. How do you convert the galvanometer into ammeter? Then for that purpose, what is a galvanometer first? Galvanometer is a small device. Okay, it is used to measure the small currents or voltages. Okay, galvanometer is a device used to measure the small currents or voltage. Ammeter can measure the large current also. Then this is I want to convert the galvanometer into ammeter. Then for that purpose, what we have to do? Let us see. Okay. Now this is galvanometer. This is galvanometer. Okay. This is the galvanometer. And now I want to convert this galvanometer into ammeter. For that, what you have to do? For example, this galvanometer is used to measure the small currents. Okay, then for the full scale deflection, the current measured by the galvanometer we can consider as Ig. Ig is the maximum current measured by the galvanometer. Ig is the maximum current measured by galvanometer for full scale deflection. What is the meaning of this full scale deflection? Okay, let us see here. Now for the purpose, let us consider this is a galvanometer. This galvanometer has the 0 at the center, and this side readings will be there 10 microamps, 20 microamps, and maximum 30 microamperes. Okay, this side 10 microamperes, 20 microamperes, again 30 microamperes. At the center it will be 0, and the maximum reading is this one 0, 10, 20, 30. This is maximum for the full scale deflection. The maximum current shown by the galvanometer is 30 microamperes. This 30 we can take as Ig. Ig is the maximum current measured by the galvanometer. Okay. The range of this galvanometer is 0 to Ig. Minimum 0 it will measures, maximum 30 it can measures for the full scale deflection, complete deflection, and then it will shows the 30 microamperes. Ig is the maximum current measured by the galvanometer for full scale deflection. Okay, and this we can also take as old reading. Why it is old reading? Before converting this galvanometer into ammeter, the reading shown by this galvanometer is Ig. Okay, maximum reading shown by this galvanometer is Ig. That's why we can take it as old reading. Okay, this is galvanometer. Now I want to convert this galvanometer into ammeter. Then what we have to do? And it was very simple. Okay, for example, I want to measure the I current by using this galvanometer. I is the new reading. Okay, new reading or maximum current measured by galvanometer after converting into ammeter. I converted the galvanometer into ammeter. After that it can measure the current I, maximum current I. Okay, for example, I want to increase the full scale deflection. The galvanometer maximum it can measure only 30 microamperes. But I want to measure, for example, I want to measure 180 microamperes maximum. Okay, Here it will measure the 0 to Ig, here it is measure the 0 to I. Maximum current I want to measure, right? Here I will write I is equal to Nig. I want to increase the current measured by the galvanometer. Previously galvanometer can measure only Ig current, but I want to convert this galvanometer into ammeter. Okay, when you convert this galvanometer into ammeter, it can measure the more current, then that is 180 microamperes. That means now here this is Nig. Okay, 6 times it is increased. The range is increased by 6 times. If it is you multiplied with 6, right, we will get 180. That means now I is equal to, we write as 6 Ig. This we can take as 6, we take as Nig. Ig is what, 30. I is 180. Then 180 is equal, we write 180 is equal to 6 into 30. Then 180 is equal to 180 we will get. That means I want to measure 180 microamperes. I want to increase the range of galvanometer by 6 times. Okay. Then if you want to increase range of galvanometer by n times, then what you have to do, what is the procedure? Okay. If you will send the large current that I want to measure I, this I is very much greater than Ig. Okay, if you send directly, this galvanometer can damage, because galvanometer is designed to measure small current, but if you send the large current, it will damage. Then for that purpose, what we have to do, in order to convert the galvanometer into ammeter, then we have to connect a small resistance. This is galvanometer. Okay, it can measure the maximum current Ig only. It can measure only Ig current. Okay, it can measure only Ig current. I am connecting a small resistance. Okay, the small resistance, that is S, connected parallel to the galvanometer. Okay, then this is called as ammeter. Now it is said to be ammeter. Now it is said to be ammeter. Now its name is ammeter. Very simple to convert the galvanometer into ammeter. What we have to do, right? In order to convert the galvanometer into ammeter, then we have to connect a small resistance parallel to the galvanometer. Okay. Now here we are sending the I current at here. We are sending I current. This I current will comes. This I current will enters. Okay, previously only Ig measures, but I want to measure the new reading, that is I. Then I am sending. Then again it will goes Ig into the galvanometer. Maximum it can measure only Ig. That's why I am sending Ig. But the remaining part it will goes to this side. Okay, after when I come to this point, it will split Ig and Is. This is I suffix S. Okay, this is I suffix S. I suffix S. This I suffix S. Okay, this is I suffix Z. I suffix Z. Okay, what happening it here? When I comes to this point, it will split into two parts, Ig and Is. Now what is Ig here? Already we know, that is current through galvanometer. Is is what? Is is the current through the shunt resistance, right? Current passes through the shunt resistance. Okay, shunt resistance. What is G here? G is the resistance of galvanometer. What is G here? Resistance of galvanometer. Okay, G is the resistance of galvanometer. And what is S here? S is the resistance of shunt. Okay, resistance of shunt. These are the terms. Then here one important point I will tell, that how do you convert the galvanometer into ammeter? Very simple. Okay, then here I will tell that the galvanometer, I will write one point. galvanometer is converted into ammeter, right? Ammeter by connecting a small resistance in bracket you write called as shunt. Okay, that small resistance called as shunt, SHUNT, called as shunt. Galvanometer is converted into ammeter by connecting a small resistance called shunt parallel to it. Okay, parallel to it. This is important point. Okay, simple it is. We are converting the galvanometer into ammeter just by connecting a small resistance, that is shunt, parallel to it. Okay, then again it will measure the Ig, but initially it is measuring the Ig. For example, Ig is only 30 microamperes. Okay, Ig is here 30 microamperes. Here we are measuring the 180 microamperes. For example, I is the 180. We are increasing the current. Range by n times. Then further what we have to do? We have to find the formula for the shunt resistance. How much shunt we have to connect parallel to the galvanometer in order to convert the galvanometer into ammeter. Let us start. Then for that, okay, I am going to rub the theory part. I am going to derive the derivation, and you note it every point. Okay, take a screenshot and note it. I am going to rub totally. Okay, I am going to derive the formula for S. It was very simple to derive the formula for S. Then how much shunt resistance we have to connect parallel to the galvanometer in order to convert the galvanometer into ammeter. This is the only galvanometer. What we are doing it here, we are connecting a small resistance parallel to the galvanometer. Okay, that small resistance is called as shunt. Shunt resistance is S, that is we are connecting parallel to the galvanometer. Then it is called as ammeter. Ammeter measures the small currents, galvanometer can measure the large current. Let us see then how we can derive the formula for the shunt resistance. Okay, from figure we write one thing, that is from figure G and S are in parallel, right? G and S are in parallel. In parallel we know potential is constant, potential difference is constant. What is the potential difference across galvanometer? Potential difference formula according to Ohm's law, current into resistance. Current is Ig, I suffix G, current through galvanometer. Resistance of the galvanometer is capital G, IR formula. What is the potential difference across the shunt? Current into resistance. Is is the current through shunt resistance, I suffix S, into shunt resistance is S. Igg equal to ISS. And but we know from figure, but the same figure, the entering current is I, that will split into part of current goes to after I current is entering it here. Okay, I current that will go split into two parts. We write I is equal to Ig plus Is. Okay, from this we write the formula for Is. Is we write as I minus, we take this Ig to left side, then we will get I minus Ig. This we substitute in above equation, then we will get Igg is equal to Is we write as I minus Ig from this equation, I minus Ig into S. Now we have to multiply this, we have to simplify a little bit. Okay, or otherwise I want to derive the formula for the S, shunt resistance, how much shunt resistance we have to connect. Then that we can directly also we can write. Then how we can write? Okay, just simple it is. You take this I minus Ig to right side, then S is equal to, you will get S is equal to, we will get as, what you will get? IgG by I minus Ig. This is the formula for the shunt resistance, right? This much shunt resistance we have to connect parallel to the galvanometer in order to increase the range from Ig to I. Starting maximum current measured by the galvanometer is only Ig, now it is measuring the I. Okay? Then if we want to increase the range of galvanometer by n times, if range of galvanometer increased by n times, okay, what is the previous reading? Ig. What is the present reading? I. The new reading is equal to n times of old reading, right? We write the new reading I is equal to, we write as n into Ig, okay, right? From this we can substitute this equation in above equation. Then from equation 1 we will get as IgG by I we write as Nig minus Ig, okay. And here Ig is common in the denominator, okay. Then we will get as here n minus 1 into Ig. This Ig gets cancelled, okay. Ig gets cancelled. This Ig and this Ig will cancel. Finally we will get one formula for the S, that is S is equal to, we will get as G by n minus 1. G by n minus 1, okay. And this is equation 2. What is G in this? Resistance of the galvanometer, and S is what? Shunt resistance. What is N? N is the number of times, how many times you want to increase the range of galvanometer. Here we write from here, this is equation we can take as 2 and this we can take as 3, okay. What is N we write here from here, okay. If you want to, you can write the N. What is N here? N is, we write here from equation 2, that is I by Ig, that is new range, new reading by old reading, right? Old reading, new reading by old reading, right? N is the new reading. I by Ig, I equal to Nig. We take n to Ig to left side, then I by Ig is n, okay, right. And this is shunt resistance. How to derive the formula for the shunt resistance, and let us you take the screenshot and note it. Now I am going to find the effect resistance of the ammeter, and the current through galvanometer how to find out, current through shunt resistance how to find out, okay, right. Okay, now what is the effective resistance of galvanometer? This we can note in the note point, okay, in note you can note it. Effective resistance of the galvanometer. How to find the effective resistance of galvanometer? Effective resistance of ammeter. What is the ammeter resistance now? That is, effective resistance of ammeter is, we will get very simply, that is, here the ammeter has galvanometer and shunt resistance, G and S, they are in parallel. What is the effective resistance in the parallel combination? That is GS by G plus S, okay. We know already formula, that is, in the parallel combination, effective resistance is R1 R2 by R1 plus R2. We know this formula. Based on that, R1 is G, R2 is S, GS by G plus S. This is the effective resistance of ammeter. I want the current through ammeter, current through galvanometer. current through galvanometer. What is that? Ig, right? Okay. And now how to find out the Ig? For that we know already, right? Igg is equal to, we know as ISS. Why? Because current to galvanometer I want to find out, that is Ig. Okay, we know already one thing, that is we know Igg is equal to ISS. From where it comes? Voltage constant. Voltage across galvanometer, current into resistance, Igg. Here current is Is into resistance, S, ISS. Then Ig I want to find out. First I changed this Igg is equal to Is, I write as Is. We know that is the sum of currents. I is equal to, we write as entering current, Ig plus Is. Ig plus Is. From that Is we write as I minus Is you want. You Ig take to left side, then I minus Ig you will get into S. Then we can simplify this, and I want to derive the formula for Ig in terms of I. Okay, then what you will get? Then for that, look at here, Igg is equal to Is, I into S. Okay, don't confuse with I suffixes, I into S, minus Ig into S. Ig taken to left side, Igg plus Igs is equal to I into S. Then here Ig is common, we'll get a G plus S is equal to I into S. Then Ig will get as, okay, with G plus S taken to right side, we can write this Is as Si also, right? Si, or otherwise Is you can write. In the next step we will write Is by G plus S. This we can write in the, by just simply modification, S by G plus S into I. Okay, this is the current through galvanometer in terms of I. Similarly, if you want the current through shunt resistance, if you want IC, okay, Is, if you want Is, you can change this Ig in terms of Is, otherwise you can use Igg is equal to ISS. You can use, you substitute Ig at here, okay, you will get the Is formula we will get as, okay, you substitute Ig, but we know that what you know, Igg is equal to ISS. You substitute Ig here, S by G plus S into I into G is equal to ISS. This S will cancel. Then finally we will get the Is formula as G by G plus S into I. Okay. This is about conversion of galvanometer into ammeter. Okay. Now next topic I am going to explain, that is conversion of galvanometer into voltmeter. Before that, let us discuss one problem based on this. I am going to rub total. You take the screenshot and note the every point. Okay, now let us see this problem. Okay, previously just now we discussed the conversion of galvanometer into ammeter. Then by using that one problem, let us discuss. Okay, solution I am going to explain. This is question. A galvanometer has a resistance of 15 ohm. The galvanometer resistance they gave us 15 ohm. the meter, the galvanometer, shows the full scale deflection for a current of 4 milliampere. We have the galvanometer, okay, this is 0 reading, and here it shows the full scale deflection, that is only 4 milliampere. 4 milliampere, this is 4 milliampere. In the middle 0 will be there, okay, the pointer will deflect and maximum of it will comes to here, and full scale deflection, complete deflection occurs, then it shows only 4 milliampere. That means the maximum current measured by the galvanometer they gave us 4 milliampere. Milliampere converted into amperes by multiplying with 10 power minus 3. Okay, and then how will you convert this galvanometer into ammeter of range 6 ampere? Okay, 0 to 6 ampere. Previously it can measure from 0 to 4 milliampere. We want to convert that into 0 to 6 ampere. For that, how much shunt resistance you have to convert? How will you convert? How will you convert? They are asking how you can convert the galvanometer into ammeter. Just we know already that we have to connect a small resistance called shunt parallel to galvanometer. Then it will convert into ammeter. Then shunt resistance we have to find out. Okay, shunt resistance we have to find out. Then for that, the maximum current, the new reading should be 6 amperes after converting into ammeter. How much shunt resistance we have to connect? We have to connect the shunt, we can find out. The shunt resistance formula we have G by n minus 1, one formula is there, or otherwise from equation 1 we write like this, IgG by I minus Ig. I suffix G, current through galvanometer, resistance of galvanometer, new reading, old reading. Okay, right, now let us substitute all the values in this, then we will get simply answer. Okay, now you try for it and then I will also continue. S is equal to Ig is what at here? 4 into 10 to the power of minus 3. What is Z here? 15 by I minus Ig. I is 6 minus Ig. Ig is what? 4 into 10 to the power of minus 3. Okay, this we write as S is equal to 4 into 15, 60 into 10 to the power of minus 3 by 6 minus, this we write as 0. How many zeros we have to write? 004, right? 10 to the power of minus 3 means this 0.004 is very negligible. When you compare with the 6, you will get the 5.996. This is, I neglect this 0.004 when you compare with 6. Then nearly I will get as 60 into 10 to the power of minus 3 by 6 I will get. Okay, and here 6 in 10 ja we will get. That means shunt resistance is 10 into 10 to the power of minus 3 ohm resistance. Means this 10 to the power of minus 3 we write as 10 milli ohm. Okay, now how do you convert the galvanometer into ammeter? Then answer is what? Okay, galvanometer converted into ammeter. Okay, galvanometer is converted into ammeter by connecting 10 milli ohm shunt resistance parallel to it. If you connect, okay, this 10 milli ohm shunt resistance parallel to the galvanometer, then that galvanometer converted into ammeter. This is galvanometer. This is Ig measures. When you connect the small resistance S parallel to it, then this galvanometer converted into ammeter, right? This is now ammeter. It was simple solution. Okay, take the screenshot and note it. I am going to explain other topic, that is conversion of galvanometer into voltmeter.